So for this part of the lecture, we will do or we will work on some more word problems. Okay. The mathematical equations or models that we will construct here will be linear equations. So let's start with our first problem. So we want to solve the following. The difference between 3 times a number and 7 is 32. Find the number. Okay, so in here we have a number, and then we multiply it by 3 times and then subtract 7, and we should get 32. So what number will that be? So let's start by giving a or introducing a variable for the number that we wanted. So let x be the number. Then according to this, okay, then we have, so 3 times a number. So we have 3x minus 7. This is equal to 32. And then from here, we can just solve for the value of x. So if we solve for x, so we have 3x, this is equal to 32, and then plus 7. So when we move this minus 7 from left hand side to the right hand side, we change the sign. So from minus 7, we move it to the other side, we now have plus 7, right? Of course, there are details in between. You add and subtract, or you add 7 on both sides of the equation, and you do your cancellation law for addition because you have minus 7 plus 7, etc. Okay? But for this one, you can do this. And this one is commonly known as the transposition. So you transpose the number from one side of the equation to the other, and you change the sign when you do the transposition. Okay? So in here, you have 3x equals 32 plus 7, or you have 3x equals 39. And therefore, you have x equals 39 over 3. This is equal to 13. So the number that we need is 13. Okay? And you can check that. If you multiply 13 by 3, that's 39. If you subtract by 7, that's 32. Okay? And I mentioned last time that when you only have linear equations, you do not do the checking part. Or you may not do the checking part because it will always give you the precise solution. Okay? So the number is, therefore, the desired number is 13. Desired number is 13. Okay? So always put the conclusion when you do your when you solve a problem, word problem. Questions? Let's look at the second problem here. The sum of twice a number and 19 is 51. Find the number. So the sum of twice a number and 19 is 51. We need to find this number here. So for the solution, we let x be the desired number, be the number here. Then twice the number, okay, 2x plus the 19 because we need the sum. So plus 19, this is equal to 51. And then we just solve this equation. So we will have 2x equals 51 minus 19. So again, we transpose this 19 from left-hand side to the right-hand side. So we have minus 19. Okay? And 51 minus 19, this is equal to 32. Okay? This is equal to 32. So equals 32. Oh, 32 or 42. I think it's 32. And then from here, therefore, we have x equals 32 divided by 2, and this is just 60. Okay? And therefore, the desired number is 16. So therefore, the number is 16. Okay? Now let's do this problem. A wallpaper hanger charges a fee of $21 plus $12 per roll of wallpaper. How many rolls were used if the total charge for hanging wallpaper is 105? Okay, so a wallpaper hanger charges a fee of $21 plus $12 per roll of wallpaper. How many rolls were used if the total charge for hanging wallpaper is 105? So in here, we are asked to find the number of rolls used. Okay, so let us solve this. We now introduce the variable. We let x be the number of rolls used, be the number of rolls of wallpaper, of wallpaper, okay, used in hanging the wallpaper. So wallpaper used in doing a job. Let's just write that. Used in doing the job. Okay. Then the cost. Let me label the cost as say capital C. Okay. Then the cost for the job is, so this capital C here, this is equal to $21 plus $12 times the roll of wallpaper, the number of rolls of wallpaper. So $21 here, it's a fixed cost. So you have 21 plus then the cost for the wallpaper. Okay, so this will be 12x. Okay, now on a certain job, the total charge was the total cost, let us say cost, the total cost was $105. So we have the following. We have 21 plus 12x equals 105. Okay, 21 plus 12x equals 105. And therefore, if we solve for x, so we will have 12x. This is equal to 105 minus 21. And this is just 84. Okay? So x will be 84 divided by 12. And this is equal to 7. And therefore, we now write the conclusion here. A total of 7 rolls were used. Total of 7 rolls of wallpaper, okay, were used. Seven rolls of wallpaper were used. Okay, questions so far? Next problem. A taxi charges $4.50 initially and $3.10 per kilometer. How many kilometers did the customer travel if his total taxi fare was $21.50? Again, a taxi charges $4.50 initially and $3.10 per kilometer. How many kilometers did a customer travel if his total taxi fare was $21.50? So we are asked to find the number of kilometers that the customer traveled. So let us introduce our variable. So let x be the number of kilometers. With the number of kilometers, the customer or a customer, okay? Kilometers a customer traveled. Then the fare, then the total fare, and let me just put this as capital F, is you have F. This is equal to the fixed amount, $4.50, plus $3.10, okay, $3.10 times the number of kilometers. So 3.10x. Okay. And then we are given that if a customer traveled and paid $21.50, so how many kilometers did this customer travel? Okay. So a customer paid a total amount of $21.50 for his/her travel or whatever. So we now have $4.50 plus $3.10 times the number of kilometers. This is equal to $21.50. So we'll just solve for x as usual in here. We will have thus 310, 3.10x. This is equal to 2150 minus 450. So this is just $17. Therefore, x will be $17 divided by 310. Okay? So we have this is approximately equal to 5.48. 5.484. Okay? So the customer traveled approximately 5.484 kilometers. Therefore, the customer traveled 5.484 kilometers. Okay? Approximately, of course. Okay? Questions? Next problem here. A man had $185 in $5 and $10 bills. How many of each did he have if he had 7 fives more than tens? Okay? So a man had $185 in $5 and $10 bills. How many of each did he have if he had 7 fives more than tens? Okay? So we want to know the number of $5 bills and $10 bills the man has. So let us start with the variables. So let x be the number. Let x be the number of $5 bills. $5 bills. Okay. And let us put another variable. Let's say y. So this is the number of $10 bills. Okay. According to this, the man had 7 fives more than tens. Okay? 7 fives more than tens. Okay? So, we have what? You have your $10 bills, which is y. So, you have y. This is equal to the number of $5 plus 7 more. Okay? So, he had 7 fives. more than the tens? Oh, let us analyze that further. So he had 7 fives more than the tens. So which one is more? The $5 bills. There are more $5 bills. Okay? So in here, what we actually have is that the $5 bills, which is X, this is equal to the number of tens plus 7. So the number of $10 bills plus 7 more bills. That's your $5 bills. So X is equal to Y plus 7. Okay? So again, he had 7 fives more than tens. So the number of $5 bills is more than the number of $10 bills. So Y, that's the number of $10 bills. You add 7, okay, to the number of bills there. That will be your $10 bills. Okay? Now, he had a total of $185. Okay? He had a total of $185. So, you have your $5 bills, okay? You have your $5 bills times the number of bills you have. So, that's your 5x plus the $10 bills times the number of bills you have. So, 5x plus 10y, this is equal to 185. Okay? So 5 came from the fact that it's $5 and 10 came from the fact that it's $10. So the number of $5 bills, that's your X, multiply it to 5, then that's the total amount for the $5 bills, or that's the total amount of contribution of the $5 bills. And then 10Y, that's the total amount of contribution of the $10 bills. But we have X equals Y plus 7. So we can replace this X by Y plus 7. So in here, you have 5 times Y plus 7. This is equal to 10Y. Plus 10Y, this is equal to 185. So now, you just have to solve for the value of Y. So if we do this, we have 5Y plus 35. This is, well, plus 10Y. This is 185. And then we have here 5Y plus 10Y. That's 15Y. And then we have 185. And then we put this 35 to the other side. So we have minus 35. And therefore, we will have 15Y equals 150. Let me use this space in here. So you have Y equals 150 over 15, and this is equal to 10. And that's the number of $10 bills. Okay? Therefore, the man had 10 $10 bills, and for the $5 bills, you have 10 plus 7. Okay? And 17 $5 bills. And that's our final answer.